Hello everyone, and welcome to the Enterprise Security Day 1 with Service Mesh talk. In this talk, we'll be looking at, do we need Service Mesh, and also how do we choose Service Mesh. I'm Daniel Wessels, a field engineer with solo.io in the APAC region, specifically Sydney, Australia. So the reason for this talk is for organizations where security is an absolute must. So like Steve from the UK car show Top Gear, security is always in place, even if it means missing out on your favorite popcorn snack. Roughly the structure of the talk will be, do we need Service Mesh? We'll look at that first. We'll use trusted security advisors and get their recommendations around Service Mesh. We'll also look at industry reports and industry business end users and what they tell us about Service Mesh. And once we've looked at why Service Mesh, we'll look at how to select a Service Mesh. And then throughout, there's really a lot of links and further reading topics and some practical tips in terms of adoption. So in the last 40 years or so in the industry, architectures and security have progressed. On the compute side, things started out as physical and went into virtual and cloud and container orchestration. On the software architecture side, we had MVC and service-oriented architectures and microservices, and now serverless is making inroads. And of course, this progress will continue going into the future, and the next new technology will make itself known. But the point is that security and the requirement for security doesn't stop just because of those architectures changing. And today in the cloud native world, we have the 4 C's, cloud, cluster, containers, and code. And this framework complements what we know in the security AAA framework to ensure that security really is business as usual and not tacked on as an afterthought. So, do we need Service Mesh? And the answer is yes. The answer is yes, if these are your requirements. This is not the exhaustive list of requirements, but they really distill most enterprise and organizations when they look at new technology and how to evaluate it. They'll be looking across these 5 criteria. And proven comes down to, has this technology been in production and proven and hardened? There is a period of time where technology needs to be used in production to make sure bugs and features are ironed out. Portability looks at not being locked into any vendor, not going too niche. Both of those will have cost penalties, and you want to be able to protect your investment and not have to look at the cost implications down the line. Of course, security and security day 1 is a key criteria. We are saying that we're not going to be developing MVP and over time add security. We are saying authentication, authorization, accountability, resilience, zero trust architectures need to be available day 1. And hybrid is a key consideration. All organizations typically have legacy applications, multiple different infrastructure architectures, and these have to work together. Your application architecture needs to work together across all the infrastructure. And in productivity, that is looking at the day two side of things, looking at operational productivity, developer productivity, adoption of new technology. How is it going to influence the operational productivity? And there we're looking for, well, organizations are looking at standardization, because standardization allows for a high degree of automation to increase productivity across operational procedures, but also developers should be decoupled from platform considerations, and they can focus on the business logic they need to be coding for. So we'll use these as we go through the next few slides and see how trusted advisors recommend across these criteria. Another thing to look at for service mesh is, of course, the business value. When you are looking at, do we need service mesh? Why service mesh? And as we said, the key business value is that it brings enterprise security day one. And then probably the other key criteria in terms of business value is that it increases the developer and operational productivity. Service mesh will decouple your developers from platform concerns, security policies, and they can focus on their business logic and coding that into the microservices. On the operational side, because there's a high level of standardization in terms of applying policy, looking at triage, operations, productivity increases a great deal as well. So our trusted advisors, as we can see here, these are organizations that have been around decades, and these are organizations that are focused on looking at technology, testing that technology, and then writing guidelines on how to securely adopt those technologies. So we're going to be looking at their points of view because most of the time, organizations with compliance requirements will be looking at these guidelines because these guidelines help with compliance. So things like PCI, DSS, HIPAA, and those sort of compliances will be leveraging recommendations from these advisors. First one is the NIST and their publication on application security in service mesh architectures. And here we see they call out the ephemeral and dynamic nature of cluster containers and the security that service mesh brings to that service discovery. It also calls out the resilience capabilities that come with service mesh, like load balancing, circuit breaking, throttling, and monitoring. And it says that service mesh is the best known approach for abstracting developers from these concerns, and they can focus on the code in the microservice. Also, OWASP concentrated for decades now on securing web applications, and they say that service meshes help reduce the complexity of communication between services in a securely and reliable fashion. It's a great solution to operational challenges within microservices architectures. It also secures the services inside your network and quickly identify and compromising traffic entering your cluster. We have the Cloud Native Compute Foundation Security Whitepaper and their recommendations around service mesh, again, highlighting the fact that service mesh patterns like traffic control, service discovery, load balancing, resilience, observability is all offloaded from the developer and allows the developer to focus on business logic within the microservice. It's also effective in securing communication in the service mesh to eliminate implicit trust. So the old models of using IP addresses no longer map into these container environments, and service mesh solves that problem. It's important to note the implementation of service mesh reduces the attack surface and is a key part of your framework in building zero trust applications. Then we see the NSA and CISA recommendations via their Kubernetes hardening guidance, in which they call out service mesh as a way to streamline your microservices communications, allowing the logic of these communications to be coded in the service mesh rather than in each microservice. It also goes further to mention that service mesh help with migration of services to hybrid and multi-cloud environments, and that administrators should be using service mesh to harden Kubernetes cluster security. Also, from the Cloud Native Compute Foundation and Kubernetes documentation, there's an article on ways not to get hacked, and it calls out the SPIFFE Foundation, and this is used within service mesh to establish identity, and really the identity allows us to build zero trust networks and ensures both parties are only able to communicate securely once they have identified themselves to each other. And we'll be looking at zero trust a little bit closer further down in the talk. Here we are looking at the end users, businesses that have implemented cloud native technologies. Gartner reporting adoption is up. The Cloud Native Compute Foundation report speaking to end users of cloud native technologies in production, and they have said service mesh in production has increased 50% year on year. And we can see that the technologies like containers in production and Kubernetes in production have also increased significantly year on year. And those are all the technologies that are driving service mesh adoption as well. So again, we say, do we need service mesh? And we say, yes, the YAML is on the wall. Part of service mesh and the business value, as we said, is being secure day one. And that is really making security seamless. And that is delivered in the cloud native world due to the fact that everything is declarative and we can automate via that declarative standardization. So it's not unusual anymore for all your security policies to be written into a manifest, and that manifest being checked into your source control, and then your CI/CD pipeline updating those policies into your environments in a securely and safe way. These aren't concepts anymore. Maturity for this type of security management is well established. And I'll call out the further reading. Have a look at the US Air Force Platform 1 DevSecOps platform. They have lots of information on their implementation, and there's nothing like a White House executive order for zero trust architectures that came out just this year to really flag that the writing is on the wall on implementing zero trust. So we've effectively understood that service mesh is definitely required within enterprise architectures. So how do we go about looking at the market and all the service meshes that are available to us? And there's no shortage of service meshes. This is, again, not an exhaustive list, but it's probably the ones that most people have heard about or have evaluated or tried at some time. So how do we really look at this? What can help us make our decisions? Service meshes really, at a very high level, is concerned about your traffic between your applications and workloads, and then the service mesh controls how the configuration of those communications between the services. And the service mesh at that application networking level need to solve these problems. And this is problems in terms of service discovery and load balancing. If the service becomes unavailable in these ephemeral and dynamic environments, how do I service remain up? How is communication between the services secured? How do we control the traffic? So we want traffic control policies like canary release and A/B testing. Also, these policies need to be centralized, and we want role-based access control to ensure that not anyone can change these policies. Of course, all of the traffic will need metrics so that we know our service mesh is performant, and we have all the observability considerations to manage and operate the service mesh. The service mesh needs to deliver resilience and be resilient and be proven in production. And then lastly, it also needs to be programmable. We want our technology and our service mesh to be software defined so that we can declare it and manage it via software development life cycles. Another key consideration to keep in mind when we're looking at service meshes is that it's a critical piece of your platform and infrastructure. You are effectively injecting a control mechanism within your request path. So it needs to be an absolutely stable and proven technology when you are introducing service mesh. Again, we have options when we look at decisions that we make between having self-managed and hosted solutions in terms of service meshes. On the self-managed side, we can think of solutions like Tanzu and IBM's OpenShift. There are many options in both camps. On the hosted side, again, we can look at cloud providers and their options in terms of managed services. And this largely plays into lifecycle management of your service mesh and de-risking that aspect of service mesh management. But key things to keep in mind as you consider these is probably vendor lock-in and the cost penalty that can have down the line. Also, typically, you need to look at how close to the upstream service mesh these offerings are, because often security patches and features only become available after a slower period of time. So another key consideration is your underlying technology of your service mesh. And here we can see that we have Envoy proxy, and Envoy proxy is the foundation for a large group of service meshes. The reason for that is that Envoy has been engineered from day one for distributed and dynamic environments. It understands the ephemeral nature of containers. And so has been used in production for many years and proven as well to be stable. So it has been adopted as the foundation for quite a few of these service mesh solutions. Again, coming into this consideration would be things like, is the technology going to be too niche? Is there any vendor lock-in? And again, the penalties associated with long-term skills and operational considerations if the service mesh technology becomes too isolated in terms of the technology it's using. Very interesting link there is to watch the Kubernetes documentary part 2, where it focuses on container orchestration, but shows how choosing the right technology is key. As we've mentioned a few times, as we look at the service mesh offerings, we want to know that it has been hardened and it has been in production and has been there for several years. And Istio is the leader in that regard. It's been proven in production for more than 2 years. Another consideration, as this is a critical part of your infrastructure, is of course support. So things do go wrong, no technology is bulletproof. Where do we go to support and fix things? Is there enough of a global and local skills set to support this technology? You know, are there vendors that you can lean on and help you and make sure that the service has enough support? And again, we don't want to be locked into any single vendor to partner with them. And here we look at Kubernetes, and there's a slide after this that will explain this consideration a little bit more, but it's definitely these days a key consideration for you is to evaluate whether this technology supports Kubernetes. Kubernetes has allowed for a lot of standardization across container and cloud native technologies, and it has brought a lot of the decoupling business value that we find out of service mesh as well. So it is key that your service mesh integrates in a seamless way and be Kubernetes native to use and understand that Kubernetes, and this will extend that skill set more globally. So Kubernetes these days have a lot of people that understand it well, and your organization probably have already adopted Kubernetes and have the people and vendors in place to help you with Kubernetes. And so if your service mesh technology just leverages Kubernetes practices, then you already have safeguarded yourself in a big way. And this explains that point a little bit more. If we look at how we got to cloud native, it all started with containers, and containers really decoupled the application from the underlying platform and languages used. A container was a isolated package that you could take and you could run it on your laptop and any container host. After that, and once containers was established to be a great developer experience, the concern became around how do we stabilize and scale containers, and that's where container orchestration started. So container orchestrations abstract the management of the container life cycles for us. And that is where Kubernetes have become the de facto container orchestration. And then building on top of all of that would be your service mesh and your application networking. And it needs to fall into that decoupling as well, where you're now addressing authorization, resilience, and traffic control, multi-tenancy. Your service mesh needs to decouple your organization from those concerns. And to do that most efficiently, it's good to be integrated with Kubernetes. Here we're looking at some industry reports. So GigaOM has done extensive market research, reaching out to service mesh users, evaluating their feedback based on the key decision criteria we've been talking about so far, and evaluating the different service mesh offerings against those criteria. And the optimal score on this report would be hitting the center, the bullseye. And we can see here that the feedback from the end users and analysis by GigaOM show that Istio is definitely hitting a leader in terms of open source service mesh, and also heading towards that ideal center score. Another report from the Cloud Native Compute Foundation, where they speak to their end user members. So these are vendor neutral organizations that have cloud native technologies in production today. This is a user group of around 140 different organizations that are sharing their cloud native architectures that they have in production. And again, they look at Istio as a key service mesh capability to recommend that to the rest of the people in the market that are looking at cloud native technologies and service meshes. So far we've seen by our own observations and cloud native businesses and industry reports that essentially Istio has surfaced as the leading service mesh implementation and recommendation. While it's not necessarily the answer for you, probably the best way to look at this recommendation is to think about it. If you don't have a service mesh, certainly start with Istio. And if you do have service mesh already, and it's not Istio, it's probably time to reevaluate or include it in your lifecycle service mesh lifecycle management for review when that comes up for your organization. So let's take a deeper look at Istio, since that's a recommendation we have come to. And I think this diagram really sums up why Istio has surfaced as becoming the de facto service mesh. It's open source, but it also understands enterprise environments. It understands that enterprises will have separate network zones and considerations. It understands that enterprises have enterprise security requirements and that all of those need to be not only addressed, but also help enterprises with implementing and making adoption of these security practices a lot easier. Yeah, we can have a closer look at the security architecture with Istio. And the main reason for the next few slides is to talk a little bit more about zero trust, since zero trust architectures are really now becoming a must-have. So Istio implements zero trust via certificates. X509 certificates, and the management of those are controlled by the Istio control plane and certificate authority. So your services living in the data plane, as they are provisioned into your cluster and the service mesh, Istio will automatically inject these certificate identities into your service. So developers do not need to consider any of this. They are building code and coding microservices and purely deploying their microservices into the mesh. And then Istio will automatically inject the identities to that service. So this is all decoupled from the developer. So as Istio injects these certificates, we are able to encrypt the traffic between these services, and also each service has an identity based on the certificate. And with that identity and authentication, we are able to start building authorization policies as well. So these are the key concepts around security frameworks, the identity and authentication, and then being able to authorize what that identity can do within your architecture. And this slide shows that a little bit more in a little bit more detail. As Istio are issuing these certificates, it will be issuing a certificate with a subject alternative name containing the service's service account. And that service account becomes the identity of that service. And then as that identity is in place and authenticated, we can use authorization policies in Istio to tell us how that identity is allowed to operate within the service mesh. Very fine grained control over what each of these services can do between each other. And Istio is built to implement zero trust out of the box. So essentially enabling this day one. So where do we start? We've seen that service mesh is required. We've had a look at the selection criteria, and we want to start using service mesh and Istio. And the recommendations really is obviously to look at your use cases. Start with finding use cases. What are the business problems that you are trying to solve? And start with those. And this is a list of the classic ones that we see a lot of clients start with. It is things like transport encryption via TLS. It is zero trust via mutual TLS. It is authorization policies between those services. Those are the classic ones to start with as a use case. After that, developers will also want to start using the resilience controls like timeouts and retries and circuit breakers and all the resilience policies that come with Istio service mesh. So those would be, two of the classic use cases to start with. On an operational side, it's important to be able to see your service mesh operating at optimal conditions and be able to detect when it's not. So a lot of organizations will have microservices architectures without a service mesh, and it's very hard for them to see and visualize their microservices application traffic. So that's another classic use case. Maybe you're not even interested in the security policies like resilience controls and TLS encryption and authorization, but you just want to have that visualization of your microservices application traffic. Or it could be related to traffic control like canary release. So these would be classic use cases, and start with maybe one of those and implement that, and really over time just phase in and layer in more and more of these policies as need be. Obviously, the ones that make most business sense to you. Adoption that we see in the market typically follows these sort of crawl, walk, and run and fly adoptions, where you may initially start at the edge API gateway and bring security in that way, but that is really limited to edge traffic. Service mesh goes into the walk phase where you are looking at architectures that are inter-cluster and inter-mesh, and you want to bring those same security policies into your service mesh east-west traffic. You'll also be looking at how do we support our service mesh, so vendors that can help you as you productionize your implementation and adoption. Key things to look for there is the long-term support. So your Istio upstream is N-1, where solo.io provides N-4 support of your Istio service mesh. We also have FIPS builds and ARM architecture builds. And then once you feel safe in terms of your adoption, the initial phases, and you are rolling out your use cases, you might come into situations where you actually find that you have a niche requirement in terms of extending your service mesh. And that's where WebAssembly comes in and WASM. So that allows you to author your own niche requirements, and Solo.io products allow you to very seamlessly and safely own that development experience as well. So all our products have built-in support for WebAssembly extending of the underlying Envoy proxy. And then really, once you pass those sort of phases, eventually you will end up in the multi-cluster and multi-service mesh environments. And that is really where Istio starts to become pretty complex. But again, the glue products from Solo.io is engineered to abstract any complexity around that and increase your security postures there as well. Once you get into multi-cluster, multi-mesh, it's also a question of how do you control your global service traffic, the routing, should a cluster or mesh become unavailable? Do we have seamless failover to where those services are available? So this is a classic adoption journey. Much of this has been gleaned from Solo.io's expert focus on service mesh technologies, working with clients. So we're a trusted vendor in this space and in this journey for you. So thank you very much for listening to this talk. Please use any of our channels to reach out to us if you are interested in continuing and starting your journey with service mesh technologies.